Okay, 2.5. 2.5 we deal with now with formulas. So all the stuff we've been learning about solving equations here, the addition property, remember that? The multiplication property. We want to use that, except at this point, hardly any numbers, and there's going to be a whole bunch of letters, a whole bunch of variables at this point. We want to be able to solve for the variable. Okay, so there's a little bit of word problems in here, and then we got the percent problems as well that we've got to deal with. So a little bit of application kind of stuff with this here. So 2.5. So formula, the formula just means an equation that contains more than one variable. So in this case, a good example is the perimeter formula for a rectangle. So you got the P, capital P is for the perimeter, you got the L for the length and width. So now in this case you have 3 different variables that you're dealing with. So let's use that particular equation here on problem number 1. It says the perimeter of a rectangle livestock pen is 38 feet. Find the length if the width is 8 feet. Alright, and geometry, if it's a geometry question, we might as well draw it out, see if we can make a diagram of it, because it's going to deal with some kind of shape. Alright, so the perimeter of a rectangle livestock pen is 38 feet. So whenever we talk about perimeter or area, what we do is we put it inside. So capital P 38. If we talk about area, we would just put a capital A inside there. Alright, anything else we know? Well, they always have a length and they always have a width. And it says find the length if the width is 8 feet. So we know something about the width as well. Okay, once we got all the information out from our word problem, now we go to find that little formula that we need. So from geometry, from the previous slide, P is equal to 2L plus 2W. And now let's plug in whatever we know. Well, we know P is 38. Get that one, that's cool. So we got 2, I don't know what L is, but I do know that W is equal to 8. Okay, for these problems, what we really need to know, what we really need to have really is one equation. So we got one equation, and then we only have one variable. In this case, it's just L. It's exactly what we want or need to have in order to solve for that variable. So let's see, first thing to do, how about 2 times 8? Just simplify each of the sides. 16 is good. And now we start solving for L. So L, I got to subtract 16 from both sides because I want to get this L by itself. So moving everything away from the variable, 38 minus 16 is going to be a 22. Alright, at that point divide by 2, and I heard 11. That works. Alright, since this is a word problem, we should answer it in a sense as a word problem here. So really you want to give me the answer as well as units. That's kind of really it. So we would say L, or you can say length is 11 feet. Alright, and we find formulas all over the place. We have formulas for practically everything all the time. Okay, let's start off with another slightly easy one here before we get to the more difficult ones here. So, very similar to the previous problem. Let you guys try it first. Can you plug in a 5 for the x? And then see what we get for the y value. Alright, let's go for it here. So, plugging in the 5 for the x. Hopefully you saw 3 times 5 has to go first. You got a 15. Subtract 15 from both sides. Again, trying to get that 4y by itself initially. Then you got a negative 8 over here. So 4y equals negative 8. Divide through by 4. And how about y equals negative 2? Cool. Good. Alright, how many got that one right before I gave the answer? Okay, cool. Alright, let's get a little tiny bit more abstract. we're going to keep both variables in there this time. So how about this one here? We're going to solve for y, and the equation is 4x plus 3y equals 12. So no more plugging in for the x. Now we're going to solve for y. So think of the y value. That's the one you want to solve for. Everything else has to go to the other side. That's kind of the way you want to think about it here. So I'm going to subtract 4x because that will get rid of the 4x on this side. In this case, it really doesn't matter which way you want to write it. You can write it as 3y is equal to 12 minus 4x or negative 4x plus 12. The reason why I'm writing it this way, because a chapter away from now, we're going to be doing this way. Be solving these here. So put the one with the x first. You'll see why next chapter as we start graphing things. Alright, let's divide everything. Now careful here. That 3 has to divide both the negative 4x and the 12 at the same time. So you got a big humongous bar line all the way across. Okay, so you can actually keep it like that. That is a perfect answer. That is just fine. The 3 does not have to divide it into these here. We'll do that later. But it's also okay to keep on going with it as well. So if you did that though, you go like this. You divide the 3 into this, and then you have to keep on going because now you have a fraction on your hands that can be reduced. So 12 divided by 3, that has to go down to this. So it's either this piece right here or this one down here. Both of those are correct answers, no problem. In terms of chapter 2.5 though, the preference is just to leave it like this for now. Just can you get that y by itself, or can you get that variable by itself? That's what you're looking for. Cool. All right, and now let's go to the toughie here. If you got this, if you can get this one, you're doing good. Whew, whole bunch of different variables. Whoa. Okay. There's an R in there. There's that. Pi actually is not a variable, it's a constant. It's a certain particular number as opposed to any kind of number. Okay, let's do this one slowly here. If you get this one, you're doing great. Don't get too scared, not that bad. Okay, let's work together. So first of all, we've got to find our variable. H is what we're looking for. There it is all the way at the end. I got this one right here. Boom. Okay, here's what our job. Our job is to move everything away from the H. Cool. So first of all, let's get rid of pi r squared. How should we do that? Subtract pi r squared. There's my variable. So subtract pi r squared here. We're going to subtract pi r squared on that side as well. So let's see what I got here. I got that cancels, right? So I got a minus pi r squared equal to 2 pi r h. Good there? Hopefully so far so good. Okay, so notice now, this the 2 and the pi and the r, all these guys are actually multiplying the h. Right? They're all multipliers. There's no addition here, there's no subtraction here. So here's what we're going to do. To get rid of them, we're going to then divide both sides by the 2, both sides by the pi, both sides by the r, and those will cancel the multiplication. Alright, again, the 2's gone, the pi's gone, the r's gone, so therefore I'm left with that right there. Notice the h is now all by itself on that one side. Okay, the only other thing that we do here is we don't like it to look like this. We don't like the condition on this side and the variable on this side. We like it to look the other way. So we like to look, our variable is on the left, and it says our variable is equal to, and then we have our condition or our formula on the right. Now, is it wrong to write it the other way? Nope, not wrong, but you'll never see it written that way. You'll always see it written as variable equal to, and then whatever the equation is. Okay. I got some other ones. Okay, what does this mean? This is actually, it's called the surface area of a cone. So if you had a cone, ice cream cone, flip upside down, we can kind of tell right here, this is how much material we needed to make that ice cream cone. That's that formula right there, based upon how wide it is and how tall it is. Kind of cool. It does connect to real life somewhere. Okay, and then we've got some other sort of unusual equations to solve here. We call these guys proportions. And the stuff that was not covered in 2.4. So notice it says one fraction here is equal to another fraction here. And I think we learned this a little while ago in pre-algebra. It says we can do this here. If you have two fractions equal to each other, you can cross multiply. And that's exactly what we're doing, except we're just doing it with variables this time. So cool, let's multiply across here. So this means it's going to be 5 times y minus 3 as we multiply diagonally up this way here, equal to the x and the 4 multiplying together give you 4x. Okay, have to solve for y. So this is the one I want to solve for right here. Eventually I want to get y by itself. So first things first, let's distribute that little 5. So 5 times y. And then 5 times a negative 3 or minus 3 makes negative 15. Bless you. I'm going to add 15 to both sides. How about 5y equal to, again, 4x plus 15. I like to write the one with the x first. And then divide by 5. And again, you can say y equals to 4x plus 15 divided by 5. That's fine. If you want to divide out the 5 on each of those, you go like this, and eventually you wind up with this answer here. So y is equal to 4x over 5 plus 3. And again, it's perfectly okay to write 4x plus 15 divided by 5. Okay, so the next few slides here, we're going to go into just a few little application sections here. That's all. So first things first, we're going to talk about angles. And we're going to talk about complementary angles. And we're going to talk about supplementary angles. And since we just did the formulas, I guess we can work with formulas now. Anybody tell me what page this is on? Let's see. I think it is. $126, I heard. Is that right? 126? Okay. So this is on page 126. We talk about complementary angles. What are complementary angles? Complementary angles are angles that add up to 90 degrees. Now, the way you would write it, I'm going to just kind of rewrite this as we go. The way you'd write it is x plus y equals 90. Good? Except, you know, I want to actually have this solved for. So how we would solve this for y? Maybe okay with subtracting x like this from both sides? So y equals 90 minus x. How's that more helpful? Is because if I have one angle already, I know to just plug it into here and I get my other angle right away. So here's really the formula that I want to use. I want to use this formula right here. Y is equal to 90 minus x. That's going to be the complementary angles. Then I also have the supplementary angles. Supplementary angles, two angles add up to 180 degrees. So if I go like this, x plus y equals 180. I want to create a formula that gives me the supplementary angle right away. That's cool. Just subtract x from both sides. And there it is. Y is equal to 180 minus x. So there's my formula for supplementary angles. Okay, we're good there? So as we get to know formulas, we can actually solve formulas for the variable that we want to solve for. Okay, so real quick here, just one problem like this. Number 6. Let's find the complement and supplement of 35 degrees. So for the complement, again, using the formula that we just created, y is equal to 90 minus x. Plug in the 35. So notice, once I did the algebra on the formula, I didn't need to do algebra again, because 90 minus 35 is just pre-algebra. Just subtracting, and I got myself 55 degrees. We good?
Yeah.
Let's see, what else did I want to say? Let's go supplementary here. Supplementary, and the formula we created is y equals 180 minus x. And again, plug in the 35. I'm just doing pre-algebra at this point. 180 minus 35 is?
145.
145 is good by me, yep. And then add a little degree symbol next to it. And there's your supplementary angle. Okay. Then jumping to something called percent problems. This is also in your textbook here on page 126. And it just gives you the whole concept of what's a fraction, a decimal, and a percent. How do we convert the two? Again, just sort of background information, something we probably should know from pre-algebra, but we know that 1/2 is really 0.5 as a decimal, or really 50%. Some more common terms would be 1/4, 3/4. 1/3 is one that repeats itself, like 0.3 repeating. 2/3 is 0.6 repeating. Again, sometimes you may need these conversions on homework just in case. 1/5, 0.2, again 2/5, so 0.4, 40%. And the whole concept of 2.5, especially the percent problems and the complement problems, is to make an equation. After you make an equation, you can plug in the values and solve. That's kind of what you want. You want to get the equation, plug in values, solve. So percent problems. Okay, this is my stuff. The book doesn't tell you this, so it's totally free. There really are two different ways to say percent problems. The first one is the amount is equal to P, which labeled as percent, times B. And this formula is really talking about A is P percent of B. That's the way we would read it. So when we get to our problem, we're just going to go backwards. If it's written like this, we're going to use this formula. The other way to write it in English is some percent of B is equal to A. And if it's this way, it's sort of like the backwards form. So it's PB equal to A. And all percent problems are going to work exactly the same way here. You've got to just know these two formulas. Go for it. Also, there's about 4 different ways to solve percent problems. The reason why the book chooses this way to solve it is because we're more learning how to plug in a formula and solve. That's kind of what we're doing. There's some other ways you can just sort of do some pre-algebra techniques. But we're trying to get into an equation. That's what we want to get to. Okay, so let's go for it here. So it says, what number is 40% of 70? Let's see. Let's go back. Backwards or forwards here? Which one? Is it the first one or the second one? What number is... Go back real quick again. I think it's the first one, right? It says, what number means I don't know what A is. What number is blah blah percent of 70? This little first way of looking at it. So I'm going to use this little formula right here. And whatever I don't know, I'm going to plug in the variable, and whatever I do know, I'm going to plug in for that variable. So A is what percent of B? That's kind of what we're looking at. A we don't know, so we're going to write it as A. And is always comes in as the equal sign. The percent comes in as a decimal, so 40 becomes 0.4 or 0.40. 70 comes in as 70. So that's cool. In this case, I don't even need to do algebra, right? Because this is really a pre-algebra problem. I just need to figure out what is 0.4 times 70. And anybody got that? 28%. I go with that. Yep, 28%. Again, 70 times 0.40. Placeholder, because no point of multiplying by 0. And then 4 times 0 is 0, 4 times 7 is 28, and I got 2 decimal places here. Therefore, bring out 2 decimal places here, and A equals 28. We'll get into some, though we have to use algebra here. Do a little bit of work. Cool, okay. All right, what percent of 35 is 7? All right, forwards or backwards, or first formula or second formula?
The first one.
What percent? What percent goes first? I think it's going to go this way, right? Easy way to look at it is where the is going to be. Is the is towards the front or is it towards the back? So what percent? That means P we don't know. That also means the B value is 35. That's the of value. And then the 7 has to be the A. So how about this? P multiplied by 35 equals 7. Alright, I've got to solve for P over here, so this is kind of unusual here. First of all, let's multiply 35 times P, which is 35P. Just get rid of that parenthesis there. Okay, not so tough here. So let's see, I got to divide both sides by 35. And I also know that 7 goes into 35. That kind of helps out. Can I divide both sides by 7? Sometimes you will be able to, sometimes you won't, just kind of depending. But I get P equals to 1/5. The only problem is that is not a percent. So if you know your table from page 126, then you're good to go. You can convert 1/5 into a percentage? 20%, yep. Okay, if that is not available to you, you can always do this here. You can always divide 5 dividing into a 1. And so in this case, 5 going into 1 or 1.0. 5 goes into 0 once. What's left over is a 1 still. Bring down the 0, also bring up the decimal point. 5 goes into 10 twice. And that is perfect. So the answer technically would be 0.2, but then remember, we have to move the decimal places twice over. And so final answer, there's 20% or from the chart on page 126. Again, each one of these is sort of like one different type of problem here. So for the first one, we did not know the A value. For the second one, we did not know the P value. For number 9, this is where we don't know the B value this time. So 36 is 80% of what number? Cool. All right, we're going to try this one. A is percent of B, and plug in everything we know. So 36 is the A value. 80% comes in again as a decimal, so it's 0.8, 0.8 or 0.80, either or is fine. But we got a formula, and this time we got to solve for B. So what should we do? We're going to divide, because notice the 0.80 is multiplying the B, right? So let's divide by 0.80, or 0.8, whichever or. So that becomes B is equal to 36 divided by 0.80. And really, we really don't need the 0 in back of decimals. We can get rid of that. Technically, this is fine right here. Except we actually still need to know what the number is. So see if you guys remember this from a long time ago. 36 divided by 0.8. What we do is we bring it into a long division. But remember, with long division, we have to have an integer over here, right? Or a whole number over here. So we have to move the decimal place once here. Therefore, 36 now becomes 360. And really what we need to do is that division problem right there. So 8 into 36 goes 4 times, that's 32. Subtract the 4 out, bringing it down, and how about a 45? Perfectly. So our number, oh, that's 45. It's not a percent, it's actually a number here. So B equals 45. So 80% of 45 would be 36. All right, 3 problems, and it was technically one of each type. First one we did not know A, second one we didn't know P, third one we did not know B. All right, and then of course, sort of like an application question with these percentages here. So Kashi trail mix bars contain 140 calories per bar, of which 45 calories come from fat. So now the question is, what percent of total calories come from fat? In this case, the sort of tough thing to do is to sort of say it in English. So what are we trying to say? We're trying to say 140 calories per bar. 45 calories come from fat. So what percent of the total calories come from fat? Let's see if this makes sense here. Aren't we trying to say what percent of 45 is 140? Or are we trying to say what percent, 45 is what percent of 140? I think the second one, right?
Yeah.
45 is what percent of 140? There you go, that makes sense. So it would be like this. So 45 is what percent of 140? That's what we're trying to do, so therefore there's our equation. All right, again, getting rid of parentheses here, so 140 times P will be 140P. Divide both sides by 140. All right, Alright, that cancels off, so 45 over 140. Don't like the p on this side. I like my variable on the left, so how about p equals 45 over 140? Still got a little problem though, because I'm trying to get a percentage out of this. Also I notice with this fraction here, it's not in lowest terms, huh? Doesn't a 5 go into both of those?
Mm-hmm.
Yeah, so 5 goes into 45 9 times. And you can check me here, but I think a 5 goes into 140 28 times. Okay, still trying to get a percent here, so let's see how this is going to happen here. We're going to have to divide this. So 9 is being divided by 28, or you can say 28 goes into 9 how many times? And we're going to have to put some decimals in the back end here, because I know we're going to get a decimal somehow here. So 28 into 90, first of all is a 0. Bring the decimal point up, so 28 into 90 3 times. 3 times 28 is 84. That's going to be 6 away from 90, so 90 subtract 84 is going to be 6. Bring down the 0. 9 times is 28 goes into 60. 2 times now, yep, that's going to be 56. Alright, that's 4 away from 60. Bring down the 0 here. How many times does 28 go into 40? Just once, because it was 20. 20 times 2 would be 40, but 28 is too big. So 1, that's going to be 28 with a little bit left over, with 12 left over. At this point we can stop, because remember when we move this decimal point, 1, 2, we're going to know what it is. The reason why we need to go one more, because if it was like 32.6, then we would have to round up to 33%, right? If it was 32.5, we still run up to 33%, but anything 4 or lower, our final answer 32.1 degrees or percent, sorry, or just 32%. I think it goes to the nearest whole number percent. Yeah, they just want a whole number percent here, that's all. Okay, another formula. This is percent formula, is another formula that's used sort of quite often here. Whole concept of with degrees. Temperature. So in the USA, we use Fahrenheit for temperature. The rest of the world, all the other countries use Celsius. We're just rebels at heart. That's it. That's what it is. From what my understanding is, when we moved away from during the Revolutionary War, we moved away from Britain. We wanted a system itself, so we were not considered British. So we made our own little system, and so we just started using it ever since, and we haven't went back. So, all right. So in Celsius, it does make sense because it's based upon water. So at 0, that's when water freezes. At 100, that's where water boils, and everything in between is set up accordingly. So it makes sense.
How do we have pounds and stuff, and then they have the metric system?
In 1970s, President Carter, he tried to move us all back to the metric system and to Celsius, and it didn't work. So we stayed. Now let's see. This is there's also a more like a scientific way to look at temperature, and that is the use the movement of atoms in a cell, and that we call the Kelvin scale. So there's really 3. All right. Fahrenheit has no bearings on anything in the world. This kind of numbers are just totally weird, off, but still use it. Okay, but there's formulas here. So if you want to go from Fahrenheit into Celsius, we use this formula right here. Of course, it has a fraction in it. And if you want to go from Celsius to Fahrenheit, we have this little formula here. All right, and this is on page 1. Thank you so much. 129. That's what we're looking for. Okay, we have to look at example number 11 from the textbook in order to actually do problem number 11. So let's take a look at this from the textbook here. Mr. McKee, who is the author, supposedly traveled to, anybody say that? Cool. I got the Buenos part. I got that too. Aries. Okay. With a group of friends. It was a hot day when they arrived. One of the bank kiosks indicated the temperature was 25 degrees Celsius, and of course they're from America, so they're like, hey, what is that? Someone asked what would be the Fahrenheit scale, and Bud said the easiest way to do it is just multiply by 2 and then add 30. So according to Bud, his little quick way of doing it is if we take the 25 times 2, which makes 50, and add 30, you get 80 degrees Fahrenheit. Pretty close. The actual way to do it is to use the formula. So there'll be 9/5 times C plus 32. If we do that, the 5 and the 25 reduce, is that right? Down to 5, so 5 times 9 is 45. 45 plus 32 makes 77. Hey, Bud is not bad. He's off by 3, that's not bad. Okay, so the simplest version is, again, multiply by 2 and only add 30. Add just a little bit less to compensate. Because what's 9 divided by 5?
90.
9 divided by 5? Yeah, it's about 1.8, right? Because 10 over here, 10 divided by 5 would be 2, right? 9 divided by 5 is about 1.8. So it's a little bit off than 2. So, all right, so let's do this one here then. So repeat example 11. If the kiosk indicated temperature of 35 degrees, so use Bud's way of doing it, and then do the real one and see if he's off. Okay, so real quick here, I don't want you to memorize Bud's formula for temperature change. That's okay, I'll give it to you. Not part of the class. So Fahrenheit is 2 times Celsius plus 30. So I'm going to plug in a 35 for the C value. So everybody okay with 100 degrees at the end? So 2 times 35 will be 70, and 70 plus 30 makes 100, according to Bud's scale. The true actual formula is, again, 9/5 C plus 32. Anybody finish that one? What did you guys get? Let's check. I think I got something different here. 67? Mm-mm. You guys are scaring me. I go with 95. Okay. So 5 and 35 reduced down to 1 and 7. So 63 plus 32. Still not bad. That's 5 degrees is still not that way off. There's probably easier way to convert things. Okay, now we are on, oh, that was going to tell you. Okay. All right, 2.6. Now we get to application questions. Whew. All right, in fact, the next 2 sections is going to be application. In fact, 2.7, all it says is just says more applications. Not too much fun here. Okay. the step at the beginning of each of the application sections, they sort of have this right here set up. It's the blueprint for problem solving. It actually was pretty good. Step 1 is just sort of read the problem. Step 2 is assign a variable. So what do you think x is? It's usually in the question at the end. Once you know what x is, then you try to figure out anything that's related to x in terms of x. Which I thought, like, that makes sense. And once you got all that information, then you jump down to write the equation. And once you got that, then you can solve it. So really, step process, figure out what x should be, any other quantities related to x, and then write the equation based upon that information. Okay, one little small thing that we got to talk about is this whole conversion, which I think you guys know. Just kind of sum means adding, difference, product, quotient means you're dividing. Whenever you're just talking about of, we just talked about it here, it means technical multiplication. Is equal sign. And then whenever we talk about a number, usually we use x. You don't have to use x, but usually we use x. The difficult ones are this one right here, this little stuff. It says whenever you talk about 4 more than x. So let's say you had 4 more than 5, or 4 more than what Charlie had. What you're really doing is you sort of write it backwards. So this one's a kind of a weird one. So more than is written backwards. You know 4 times x, that's fine. But the bottom one over here, also same thing. If you say 4 less than x, what you do is you're going to have to write it backwards. You say 4 less than something that you had already. 4 less than a dozen, or 4 less than what the other person had. We good? So write those backwards. These two work backwards. More than and less than have a backwards way of writing it. Okay, so let's start off. Start off easy here, work our way up. So the sum of twice a number and 4 is 18. Find the number. Alright, again, what we're going to do is we're going to have to label what in the world is x. Once we label what x is, we can figure out the rest here. So in this case, since we're trying to find the number, I guess x would be the number or a number. Good there. Okay, then it's the sum. In this case, we can go directly to equation here. So the sum means I'm going to add something, right? And I'm adding something over here and something over here. So I'm adding twice a number, and what we do is we always read all the way up to that and statement right here. So whatever is before the and, twice a number, that goes over here. Whatever is after the and, that's what we're adding with, so that's the 4. Once you get to an is statement, you got yourself an equal sign and 18. So everybody good with that? Declare the variable. This was an easy one here. This should be going right directly into an equation here. Alright, let you guys solve it if you haven't done so already. So drop the parentheses because there's nothing to distribute. Subtract 4 from both sides gets you 2x equals to 14. Divide by 2 and x equals 7. And we found the number. That's not bad. All right, let's get a little bit more complicated. So one number is 5 more than twice another, and their sum is 29. And I got 2 numbers to find because there's plural now. Alright, since there's 2 numbers to find, I don't know how you want to put this here. You can put it one number, you can put the first number as opposed to the second number. You can do a whole bunch of different ways to write it. But as long as you have something called a number and another number or something. So x is going to label as one number. So this one has a relationship here. It says one number is 5 more than twice another. 5 more than twice. 5 more than. Hey, that more than stuff, huh? So it's 5 plus twice another. There it is. There's your 2x plus 5. Good there? That's going to be the other number. You can also label it as the second number if you like. This would be labeled as first number. This is second number. It doesn't matter. But you have a relationship between the first number and the second number. Okay, and here's their relationship. Their sum is 29. So can you write that into an equation? I think so. X comes down. That's the first number. Adding with the second number, grand total is 29 and solve. Alright, combining like terms, I get a 3x now, subtracts 5 from both sides gets me 24, and how about dividing by 3 would eventually get me just a regular old 8. Good there? Now, that is just one of those numbers, right? Because let's find both numbers here, so that means if I go over here, there's my relationship. So this is going to be 2 times x plus 5, which would be 2 times 8 plus 5. Anybody with that one? That's going to be 16, right? 16 plus 5 would be 21. Everybody good there? Now, something we should have done on the first slide as well. When we finish this off, you just can't put x equals 8 and the other one equals this. You have to sort of write it out. So you can say the numbers are 8 and 21 or something. On the first slide, we probably should have put the number is 7 or something. So let's take a look at, let's say 3 more problems to go. And maybe each of them are sort of like the basic word problems you guys will see in algebra. So we'll start off with the basic one here. We call it the age problems. It has to do with age. And they work a certain way. Then we're going to go to the geometry problems, which will work a certain way. Then we'll go into some coin problems again, which will work a certain way. Okay, how do we set this up? Joe is 4 years older than Tim. 10 years ago, Joe was twice as old as Tim was then. Find the age of each boy. And so I got myself 2 things here. J is for Joe, T is for Tim. And I'm going to have to label something here. I'm going to label what in the world is X. And so this first line, let's slow it down just a little bit here. Joe is 4 years older than Tim. So would X stand for Joe's age, or would it stand for Tim's age? Hey, cool. It would stand for Tim's age, because Joe is being related to Tim somehow, right? So Tim's age. And what we do is we put a little X next to T for Tim. Joe is 4 years older than Tim. So are we okay with that? 4 years older. It's kind of like 4 more than Tim. And this is what's happening now, because this is right, it's now. Okay, so we've got the first sentence all taken care of. We've got the relationship between them now. It says 10 years ago, Joe was twice as old as Tim was then. Okay, so let's go backwards then. 10 years ago. Joe, sorry, I had to move things around here. Joe is x plus 4, but we're going to subtract 10. Is that good? Whatever Joe's age is, we're going to subtract 10 from it and simplify it. How about x minus 6? We're good. Alright, Tim is x years old now, so 10 years ago he would be x minus 10. Does that make sense? If he's x, that means 10 years ago he was x minus 10. Alright, now let's see what this see. 10 years ago, we got this. This is your 10 years ago scenario. Joe was twice as old as Tim was then. So Joe was, or is, right? There's my equal sign. So we're just reading the sentence here. Joe was twice as old as Tim was then. So there's my x minus 10. Number 3 won't be on the test. Is that
Nothing like that?
nothing like that?
Okay.
Nothing like the H problems, no. Okay, so let's simplify this here. Once you get to the equation, then it becomes easy. Should be able to solve it from here. Distribute the 2 out, so 2 times x, 2 times negative 10 minus 20. And let's see, let's move all the x's over to the left-hand side. So x subtract 2x makes a negative x, minus 6 equals to negative 20. Running out of room here. Let me just add 6 to both sides, but let me do it over here. That's going to be negative 14. Again, divide through by negative 1 to get rid of the negative there. And we get x is equal to 14. And let's see if this makes sense here. I'm writing as a sentence here. So Tim is 14 years old and Joe is 18 years old. Does that make sense now? Tim is 14, Joe is 18. If you go backwards 10 years, that means Joe would be 8 and Tim would be 4, and Joe would be twice as old as Tim. And again, just getting sort of like more like a feel for word problems here. Okay, let's do 2. The next 2 you do need to know. So we got the geometry problem, and then we're going to have the coin problem. Alright, so the length of a rectangle is 2 inches less than twice the width, and the perimeter is 26 inches. So again, find the length and the width. We don't know either, but if it's a geometry question, I'm going to make a little diagram, and I'm going to put down everything I know. Alright, rectangles have length and width. That's cool to me. And the relationship there is 2 inches less than twice the width. then we also know that the perimeter is 26 inches. And this is similar to the one that we were doing in the previous section. So for these geometry questions, yes, we need to go back and find the geometry formula. And how about P is equal to 2L plus 2W? We're going to plug in whatever we know. So do we know what P is? 26. Perfect. 2L plus 2W, that's fine, but eventually we're going to, I just wanted to show you this one because here's our problem. Notice, bless you. Notice you have one equation here, but you got two different variables. You can't work with those. There's no way to work with one equation, two variables. You've got to get to one equation and one variable. So we do know how a relationship right here. L is really the same thing as 2W minus 2, so let's plug in a 2W minus 2 right into here. So L has been transformed. Notice also I need to put in parentheses because this was a single number. Now I have two numbers. Alright, can you solve it from here? Let you guys try to finish it off. Alright, distributing the 2 here, hopefully did that. And hopefully got to 6W minus 4. As you combine the W's, adding 4 to both sides gets you that 30. Divide by 6 gets you a W equal to 5, or 5 equals W. Alright, so now if W is equal to 5, you guys tell me what would be the length then?
5.
Perfect, yeah, plug in the 5 into here. Two times 5 is 10, subtract 2 is 8. Alright, and then we've got to write it out sort of in an English sentence to sort of make sense of what we're trying to say. So how about this? Will this work? It says the width is 5 inches, and again, include your units, and the length is 8 inches. Alright. And the coin problem, of course. Here it is, last problem of this section. Alright, Jennifer has $2.40 in dimes and nickels. If she has 6 more nickels than dimes, how much of each coin does she have? And again, really just practicing what you don't know and trying to get numbers into the circumstance here. Alright, this works by filling in this grid, and if you can fill in this grid, this works exactly the same way, bless you, for mixture problems, which we'll get into next. Something called work problems, same exact process. If you can fill in this little grid, you got it. Alright, so first of all, you got nickels on top and you got dimes. Alright, on the row values here, you're always going to have the same here. The first one's going to be number, the second one's going to be value. Number is just the number we have, value is how much it's worth. Okay, so let's see this. If she has 6 more nickels than dimes, I guess the nickels are being related to dimes, so the x will have to be just be the number of dimes. Because the relationship is set up to be what are nickels to dimes. Alright, once we get to that point, I think the rest should be easy here. X would be the number of dimes. What would have to go here for the number of nickels?
6.
Not just 6. She has 6 more nickels than dimes.
X plus 6.
X plus 6 is perfect. Okay, and to make things a little bit easier, instead of the value of a nickel as being like 0.05, we don't want to do that. We're just going to say in terms of cents. So a nickel has a value of 5 cents, a dime has a value of 10 cents. The total value has to be $2.40, but in terms of just cents themselves, we okay with doing this 240 cents? Makes it a whole bunch easier, so let's do this here. Let's just multiply straight down. So 5 times x plus 6 plus the 10x would give us a grand total of 240 cents. And you guys get to solve it. Alright, distributing the 5 hopefully. Collecting the x's on the left hand side gives you 15x. Let's see, subtracting 30 from both sides give you 210. And then we gotta divide both sides by 15. Anybody, how many times does 15 go into 210?
Is it 13? 14?
14? I'll go with 14. Try, take a look at it just to make sure. 14, yeah, 13 would be 15.
14,
So that,
yeah.
yeah, 14. Cool, awesome. Ah, see, I did it on the side just to make sure here. So 1, 15, like 6 left over, and there'll be 4 to give you 60. Perfect. Okay. But x equals 14 doesn't tell me anything. But I know that x is the number of dimes, right?
Yes.
So how about this? How about saying, okay, there's going to be 14 dimes and 20 nickels. That would be an answer to the problem. Alright, 2.7, it actually only has 3 problems here. A little bit long, but I think we can probably go 3 problems here. Before we get to problem number 1 though, we're going to have to do a little bit of work about something called consecutive integers. Did we talk about consecutive integers in the class before or no? No. Okay. Alright, let me start off, again, this is sort of doing a little bit of pre-algebra here, just to connect. I'm going to start off with consecutive integers. We're going to also take a look at consecutive even integers, and then how does it differ from consecutive odd integers. Got to do all 3 here. Alright, so let's start again. This is something, let me just check if the book talks about it. It talks about a little bit here. Alright, let me start writing down leave a little space here for each of these here as well. So how about this here? I'm going to start writing down consecutive integers, randomly starting at 4. There's nothing special about 4. But if I start off 4, so 4 goes to 5, then goes to 6, then goes to 7, then goes to 8. On and on and on. So what we want to do is we want to find the relationship between these numbers as we come across. So for integers, yeah, all we do is we just add one more to each one, right? So how about this? If I just start off with x, I don't know what the first number is. How do I get to the next integer? Yeah, I just add one more to it, right? If that's, let's say that's 12, the next integer would be 12 plus 1 is 13. How about the next one? Now you're going to add x plus 2 this time, right? That's going to get you the next one. And we can do this forever and ever depending on how many we need, right? So it goes on for x plus 3, x plus 4, x plus 5. Okay, how about consecutive even integers? How do they work differently? Again, starting randomly at 6. There's no reason why I have to start at 6. I just sort of started. 6 goes to 8, 8 goes to 10, then to 12, then to 14, then forever and ever. Alright, how much am I adding each time to get to the next even integer? 2, of course. So if I start off with x, I'm going to have to add 2 more to get to the next even integer, and then 4 to get to the next one, and again 6 to the next one, 8 to the next one. Alright, here's where the confusion begins. So let's see if we can go through this confusion. I'm going to start listing down odd integers. Ready? Starting at 5 for the fun of it. It's 5, 7, 9, 11, 13, blah, blah, blah. So here's my question to you. Is how much do I add from one odd integer to get to the next odd integer? Yeah, I still have to add 2, right? Because our numbers are actually even, odd, even, odd, even, odd, even, odd, right? They just sort of skip. Okay, so if I start off with x, what do I need to add to x to get to the next odd integer?
4.
Just 2, right? And then get to the next one, be 4, and then on and on. Cool, so if you start off with an odd number, you add 2 to get to the next odd number. Good? If you start off with an even number, if you add 2, you're going to get to the next even number. Good there?
Mm-hmm.
I'll let that sort of sink in. I've got about 3 people in the audience with like totally blank stares. Like they just saw something weird. Okay.
Is it always going to be even for the odd integers?
It's not so much it's going to be even, you're just going to be adding 2 and then 4 and then 6 because our number line, remember our number line goes like this. Our number line goes even, odd, even, odd, even, odd. So if you're starting on an odd number, you got to skip that even number, so you got to add 2 more to get to the next odd number. Good there? Okay, just let it sink in for a little while. Good. Okay, so let's go with number 1. So the sum of 2 consecutive odd integers is 84. I need to find those 2 integers. So as we did before, we're going to have to label what in the world is x. And x you can say is one number, you can say the first odd integer, you can say the first integer, whatever you like. Alright, so the first one is x. What's going to be the second consecutive odd integer? X plus 2 is a good one. That's going to be the other number or another number or the second number, whichever you like. Or the other odd integer, if you like. Okay, I think I got all my variables, right? There's 2 of them. Okay, I know that the sum of those guys is going to be equal to 84. So can you write an equation based upon that information? What I like to do, I like to always put in parentheses when I write. So that's the first number. This is the second number. If I add those guys together, it should give me 84. Okay, and then notice there's nothing to distribute. There's no 2 or 3 or 5 to multiply in, so we could just drop the parentheses right away. And let's see, collecting like terms, x plus another x would make 2x. Subtracting 2 from both sides gives me 82, and divided by 2 it gives me a 41 at the end of it. Alright, and the only question here is 41 an odd integer?
Yes.
Did we get what we wanted? Yep. So that means, let's see, the next odd integer would be
43.
43. Awesome. So the integers are 41 and 43.
Do we have to do it like that?
No, there's a few little tricky ways to do it. You could do it.
I just didn't know if like there was a method to why like you want us to set it up that way for something else.
Ah, no. The reason for why it's doing this is, again, it's algebra. We want to go from problem to an equation. Once you get the equation, to solve it. So you sort of want to get that step process in. There's a few little pre-algebra tricks you can do to sort of think how you can do that. All right, going on to number 2. Oof, got lots of stuff here. Now we wish we would have printed out the matched problems, right? Okay, suppose you invest a certain amount of money in an account that earns 3% annual interest. At the same time, you invest $2,000 more into an account that has 4% annual interest. Total interest for both accounts is $535. You want to sort of backtrack to see how much was invested in each account. This is one of those problems in math, like in real life it doesn't make sense, because you better know how much you invested in each account. And then how come you don't know the relationship between it, but you know the relationship between them, but you don't know the exact amount? Doesn't make sense. Anyways, let's go for it here. Figure out what in the world is X going to be for us. X is going to be the first investment, or the 3% investment, or you could put the one investment and put 3% behind it. All right, then we got a second investment, and what's the relationship there? At the same time, you invest $2,000 more. I think that would be X plus 2,000, right? So there's the relationship there. And again, second investment, another investment of the 4% investment, whatever you want to label that as. Alright, so let's start putting this together in an equation here. So let's see if this makes sense here. The interest earned from the 3% investment plus the 4% investment was $535, right? So if that's the case, see if this makes sense. It's going to be 3% of this amount right here, right? It's 3% of this. But whenever we enter percentages into equations, we got to change them into decimals. So see if this makes sense. It's 0.03 multiplied by how much you put in, and it's 0.04, the 4%, multiplied by how much you put in, for a grand total of the interest earned completely. And again, by 3 different ways to do this kind of problem as well. But since we're just sort of practicing getting stuff into an equation, there it is. Alright, if you want to go ahead of me, go for it. And if not, let's do this together here. So I've got to distribute the 0.04 into x. That's the easy one. 0.04x. 0.04 times 2,000 would get you 80. All right, 0.03 and a 0.04 added together would give you a 0.07. If you think about 3 cents and 4 cents make 7 cents. All right, what should we do here?
Subtract 80.
Subtract 80 from both sides. I go with that. Boom, that would be 455. All right, on these type of problems, if you want to, you could just use a little calculator to finish it off, if you like. As long as you know what you're doing, divide through by 0.07, so 455 divided by 0.07 turns out to be exactly $6,500. All right, in the English sentence, can you finish off the problem? What does it mean X to be 6,500? What does it mean in terms of the other investment? Can you sort of summarize the answer in a single English sentence? All right. Got a few people still writing it out, so wait a little bit. That's what I wanted to do. All right, here's what I got. I got in dollars, because I put dollars in here. So $6,500. And you say invested at, or at 3%, and $8,500 at 4%. You've got to distinguish between which, how much and which one, because you had two different things you were sort of trying to find. So again, any variation of that sentence right there. So you could say, I invested all right, and last problem here for 2.7. Before we get to the last problem, we got to do one more little thing here. A little fact from geometry is whenever we have a triangle, doesn't matter what kind of triangle, but these little angles right inside here. This is called angle capital A or angle A. This is called angle B, angle C. We have a little relationship here. On any angle whatsoever, if you were to add up all the interior angles, the angles that are inside the triangle, they will always give you 180. That's what this says right here. So A plus B plus C equals 180.
Because it's
Not so much because it's flat, just the angles inside here. So I'm looking at this angle here, so capital A, angle capital B, and angle capital C. If I were to add these angles up on any triangle whatsoever, they'll always equal 180 degrees. Now, a whole bunch of different ways to prove it. I'm not going to do it here. If you take any kind of the fun way to prove it, I used to do it with my geometry class in high school. We used to take any triangle. They used to cut up. The kids would cut up any kind of triangle whatsoever, any shape whatsoever, and they would tear this piece off. They would tear this piece off and this one, and when you put it together, it always becomes a straight angle. All of them will always become a straight angle. Maybe we'll do it during break. So let's go for it here. So the angles in a triangle are such that one angle is twice the smallest angle, third angle is 6 times as large as the smallest angle, all that good stuff there. Find the measures of all 3 angles. Let's take a look at it here. So first of all, it's a geometry question, so might as well put up a little diagram of a triangle. And I'll label this as A, B, and C. And so for triangles, capital letters stand for angles. And then if you want to sort of know a little bit more here, lowercase letters stand for the length of the sides. They're always opposite each other. So little b, the length of this side would be this one, and little c would be over here. That's kind of how we label a triangle. So capital letters are the vertices or angles, lowercase letters are the sides. Okay, but we are interested in this right here. We're interested in this here, this angle, and this angle. There's my interior angles. So let's see, the angles in triangle are such that one angle is twice the smallest. The third angle is 6 times as large as the smallest angle. Everything is being compared to the smallest angle, huh? Is that right? So let's do this here. X equals, let's put smallest angle. Let's see, any other comparisons here? Let's see. One angle is twice the smallest angle. So 2x, 2x. And again, you could put second angle. I guess we could put second angle. You could put one angle, whatever you like. As long as you know. So smallest angle I got, my second angle is 2x. Whereas the third angle is 6 times as large as the smallest angle. Okay, that's cool. That's 6x. That will be my third angle then. Cool, got that. All right, and this little relationship that comes up again, A plus B plus C gets me 180. As long as we can put it in, that's fine. Again, I like to put parentheses because then if I go back on my problem, I know exactly what I plugged in. My B angle, my C angle, what gives me 180. Nothing to distribute, so the parentheses just sort of drop out. But again, at least I know what I plugged in, so in case I need to go check my work. Let's see, 1 plus 2 is 3, plus 6 more is 9, is that right? 9x? So 180, divide through by 9, divide through by 9. And what'd you guys get? X equals 20, perfect, okay. So let's go back over here. And so the 3 angles are, and the whole thing is include your degree symbol in it here. So all yours, what do you guys say?
20 degrees.
20 degrees?
40.
40 degrees, because that's that second angle that's doubled.
120.
Cool, and 120 degrees. There it is. Okay, good there? Let me do